Okay, so welcome back to another video in our video series on college algebra. Today's video will be talking about translations of graphs, and basically what that means is you're shifting a graph. It's basically transformations. So you're moving a graph from what's called its parent function. So that's like the graph of just the very basic function, and you're sliding it left or right, up and down, and you're also making it bigger or smaller, or like narrower and stretched, elongated, or like really wide and kind of like squished. And so all that has to do with numbers that you add to your equation. And so to find those, you just kind of follow some pretty basic rules. And once you have those rules, it's really not too bad. The best way to do it, if you get confused using these rules, you can always just kind of look at your equation and think, okay, what's the parent function? And graph that in your graphing calculator, and then graph the equation you're given and kind of say, okay, how did I go from my first graph to my second graph? And that's all they're really asking for in answering these questions, right? And so before we get into like some pictures and kind of how to answer some of these questions, let's just kind of go over some of these four or so basic rules. So our parent function that I chose is y equals x squared. Its graph looks like this, right? So you have an xy coordinate plane, right? It's the minimum or the bottom of your parabola goes through the origin, okay? And both arms are going up because the equation is positive, right? So now we have this new equation, y equals x squared plus 2. Right, so whenever you see this plus 2 or plus any number, that means the graph is moved up, or you move the graph up. In this case, it's moved up 2 units. So what do I mean by that, right? So the bottom of your graph, the minimum, is now not at y equals 0, 0, but it's now at y equals 2. So the graph of this would look something like this. So now your graph has moved up 2 units, right? Now, at the same, kind of on the same, like on the flip side, if you have y equals x squared minus 2, the graph is moved down 2 units. Okay, so the picture should look something like this, right? So now the minimum is now at y equals negative 2. So that makes sense, plus something you move up and minus something you move down. That's, it's very intuitive, right? Now, where it starts getting kind of wanky, and I use that phrase with all my students, it gets weird. Is when you start adding plus or minus numbers on the inside, so with your x, and it's squared, okay? And what these do, these two numbers, these two next equations, these are going to start moving your graph left and right, okay? Now, it's counterintuitive to what you would think, right? You would normally think, okay, plus 2, okay, the positive side of the graphs, like the xy graphs, is to the right, so I must be moving my graph to the right. That's wrong, okay? Actually, when you have x, so your equation y equals x plus 2 quantity squared, the graph is shifted 2 units to the left, okay? So whenever you have plus, you always shift it to the left that many units, right? So your graph would look something like this. So 1, 2, right? So my origin or my minimum would now be like this, right? And then x plus or x minus 2, so y equals quantity x minus 2 squared, right? The graph is shifted 2 units to the right. Okay, and so, you know, again, your graph would look something like this. Now, you know, if it was just one of these 4 type equations, right, that would be really nice. You know, it's college algebra, so they like to test you. So they're going to be putting a lot of these equations in, and we'll see some of these towards the end of this video. You'll see kind of how they can, you know, shift a graph left and up, or left and down, or right and up and right and down. And, you know, when they start adding, your equations start getting more and more complex, right? Now, this is where it gets a little confusing. This is what's called a non-rigid transformation. So this is, so rigid, if you remember from geometry, remember rigid motion is a motion that you change position. You do not change size, right? So you're like in these first 4, you're moving it left, right, up, and down. But in these next few, what we're going to be doing is we're going to be horizontally and vertically stretching and shrinking the graph. Okay, and it all depends on where the numbers add in your equation, right? As well as what, like, the actual number itself. Okay, and so, for instance, if you have, like in your book, the book that I have, it outlines it in terms of like kind of this general notation, and then I have an example. So it says y equals cf of x, right? Well, when when your value of c is greater than 1, it's a vertical stretch. So meaning that you're elongating it vertically, right? And then when c is between 0 and 1, so basically it's a fraction, right? You're horizontally shrinking it, so you're scrunching it down. Okay, so for instance, if you have y equals 1/4 of f of x, how would you determine what your graph is? Well, with these type of questions, it's all, you know, if you look at this table, right? C is 1/4. Well, 1/4 is not greater than 1, so it's not a vertical stretch. This would be a vertical shrink, okay? And so here's what you do, right? So vertically shrink. If you think about it, vertically shrinking, so you're basically, your y values are getting less, okay? They're not vertically stretching when, you know, your y values are getting bigger, right? And so what you do is you take some of these coordinates. You know, normally I would use 0, 0, but 0 times 1/4 is not going to really, I mean, it's still 0, right? So what you do is you look at some of these coordinates. So I'm going to pick this coordinate. So this is 3, 2. That is a terrible 3. Let me rewrite that. So this is 3, 2, okay? And you can do this for another point too, but what you do is you take, because it's a vertically shrink, right? So you're going to basically take your y value, okay? And you're going to vertically shrink it. So you're going to take it times 1/4, right? So if I take my number y equals 2, so I take 1/4 times 2, this would be 1/2. So this point stays at x equals 3, but now in my new graph, right? In my new graph, let's change this color. Well, let's keep it red. So in my new graph, so 0, 0 is going to stay the same. Okay, and then 3, right? Now, 1/4 of 2 is 1/2. So if this is 1, so this point went from y equals 2 to y equals 1/2, right? And this point right here, this next point over, this would be 1, 2, 3, 4, 5. So 5, 5, 2, you do the same thing. So this would be 4, 5. So down here, right? So your graph would look something like this, the top part of your graph. And then this point is 1, -2. So -1, -2. Well, -2 times a half is -1/2. So -1, so right there. Right? So if you looked at it, your graph is shrunk. So basically it's like squished smaller. Okay. Now, on a different note, when the C is inside, okay, when the C is on the inside of your equation, you basically it's a horizontal stretch or a horizontal shrink, depending on what your C value is, right? So for instance, you have, if C is greater than 1, it's a horizontal stretch. So your x's are getting bigger. And then if your C value is between 0 and 1, so it's a fraction, then it's a horizontal shrink. So you're compressing it together, okay? So just like the last equation, right? You look at your coordinate. So this would be 3, 2. This would be 5, 2. Right? 0, 0 is not a good coordinate to look at because 0 times anything is still 0. So you're still going through the origin. And this is -1, -2. Okay, so if we look at our new graph, okay, so we go through 0, 0, of course. And then now this time, instead of looking at our y's, because we know it's a horizontal, we're going to be using in our equations y equals f of 2x, right? So C is 2. So I'm going to take my x coordinate this time, so 3, and I'm going to multiply it because it's a horizontal. Just like before, I'm going to multiply, so 3 times 2 is 6. So this point right here, this point goes out 1, 2, 3, 4, 5, 6. 1, 2, okay. And then this point 5, so 5, 2, which is 10. So 6, 7, 8, 9, 10. So it's way out here, right? And then let me erase this line. That's bad. Okay, and then -1. So -1 times 2, which is -2. So 1, 2, 1, 2. So it's down there. So basically, your graph has gotten way long. Okay, and like I said before, kind of going back to the above 4. So this is if these are kind of wanky. I know, especially with C being with F and with, outside of your function or inside your function, and you may be like, what in the heck? So here's an example. Let's do one more example. So if we look at, let's go back to y equals x squared as our, what's called our parent function, and let's create a new equation. So let's say y equals, let's say 2x minus 2 squared plus 3. Right? So we don't really have to graph it, but we can kind of break some stuff down and say, okay, this is what's happening, right? So because of this plus 3, because of plus 3, we have our graph is shifted up 3. That's really easy to spot, right? Because of, let me change colors. So let's go orange. Ooh, orange. Okay. Because of this -2. So because of -2, right? It's on the inside. So that means I'm moving the graph left and right because it's minus. I actually move right. Graph shifted right 2, okay, and then let's go blue, right? Because of this +2, or because of the 2 is on the inside. So because of the 2 is on the inside, right? it would match this right here, right? So the 2's on the inside, and 2 is greater than 1. So we have a horizontal stretch. Okay, so because of the 2 on 2x, right, graph is horizontally stretched. By a factor of 2. Okay, so a lot of times they'll ask, you know, A, B, C, D, and they'll have a bunch of things listed, and you just have to find that. If you actually graph this, and if you graphed y equals x squared, and you graphed y equals 2x minus 2 squared plus 3, you would see all these things. It's shifted up 3, it's shifted to the right 2, and it's a horizontal stretch by a factor of 2. Okay? If you have any questions, please leave it in the comments below, or you can email me at my email in the description. Thanks.